Okay, thanks, Douglas. Thanks for all of you joining in. I've got a quick 30-minute session on do's and don'ts of big data analytics. These are basically a compilation of kind of major things that I have learned in my many years as a data science practitioner, which has involved both the use of just doing reporting and analytics as well as building models. So that's hopefully my objective today is to really give you a sense of some of the major themes that I've encountered over my career. So the first one, which I think is probably obvious, is identifying the right problem. And the issue here is really about listening and trying to really acquire as much domain knowledge about either the industry or the company that you're working with. And once you're able to do that, you're able to really frame and identify the problem correctly. So here's a good example. Take a look below. Um, Douglas, I think somebody's got their mic on. Anyways, okay. Thanks. So here we have a situation where a company has a 50% defection rate. The company has a 50% defection rate. Yeah. Is data science or big data analytics going to really help there? Probably if I had a 50% defection rate, I'm going to be looking at other things around my business, such as the competition, what are competitors doing, my pricing, and I really probably don't need to do too much big data analytics to try and understand really what's going on. So this is really just about trying to really identify the right problem, and more importantly, whether or not big data or data analytics can help us solve that problem. The other holders on side. So if you're developing a project, the key is to make sure that all the players, all the people that are involved are on side, have the same expectations in terms of deliverables that you're doing. I've found, and certainly in my early days, that the projects that did not go the best were the ones where there tended to be minimal communication. So having that, having an enhanced level of communication between all the stakeholders, and making sure that communication is ongoing is key to achieving any success in a data science or big data analytics type project. Tip 3 is create quick wins. So back in my early days, we had to sell a lot of the work that we were doing. This was even internally. I wasn't a consultant back then. I was working with with American Express, and so we were always thinking, what were some quick ways to establish quick wins that would yield something that the business people could understand. And so we were always thinking of looking at solutions that were, one, easy to implement, and that they just demonstrated significant business benefit. So some good examples is RFM, which is basically taking a look at historical data. You take a look at previous purchase behavior of customers, and simply go in and determine when did they last purchase, how often do they purchase, and what's the average amount of that purchase, and then simply creating indexes on that, and then using that basic information to go back and target customers and to demonstrate the business benefit of that. Another example could be a quick predictive model, where, and often enough, what I've done is, if they're looking at at incorporating modeling as part of their discipline, one of the best ways to demonstrate that is through the use of retention or defection models, trying to predict the likelihood of somebody defecting, and then showing the business benefit of being able to target those high risk, high value defectors, and what you would attain by saving some of them. And so this is another example creating quick wins. This is an example of a report. This was done for an insurance company, whereby we were trying to look at high value. We were trying to segment their policyholders or their insurance customers into value. And in this way, we were trying to say, okay, who are their high value insurance customers or policyholders, and who are their lowest value? And what this report demonstrates is that Pareto principle, that 20% of their customers are really achieving or delivering 56% of all the value to that insurance company in terms of premium, while the bottom 60% are only generating 20% of all the value of all the value that would go to that insurance company in terms of premium. So it really demonstrates this Pareto principle of the old 80-20 rule. 20% are delivering 56% of all my revenue, so to speak, while the bottom 60% are only achieving 20% of all my revenue. Tip 4, again, and probably my most important tip. Why? I am, as a data scientist and practitioner, yes, I've always been aware of the math and the tools that are readily available to me, but I've always believed that it's the data that underlines it that is the key to success, and more importantly, what we do with that data. So that is incumbent upon us to really go in and understand the data. So we have a process, or the company that I used to own had a process that was pretty standard, where we went in and we did three things. We looked at the data, we loaded it, we did some data diagnostics, took a look at missing values and cardinality, and we did some frequency distributions. So here's an example of a data before I do that. So this is kind of the process that we undertook. Load the data in, try to identify what variables are going to be useful by looking at cardinality type issues as well as missing values. And then the third type of report that we did was frequency distribution. So there's three types of reports that we ultimately worked on during this data audit process. I'm going to show you the second one, which is the data diagnostics report. In this report, and I'm not going to explain every different row, but in this report, the key thing that we're looking at is missing and unique values. And this tells us, these two columns, unique values and looking at the missing values, tells us about cardinality, and also, again, which variables are going to be useful for any future analysis. So if I take a look down here, in terms of rows, these variables, which are going from row 20, 21, 22, etc. Most of those variables are all above 90%. So any variable that's above 90% in terms of missing is not going to be useful in any future data analysis. Cardinality, a good example of cardinality is if I had a variable that only had one outcome, obviously that's not going to be useful in any future data analysis. Here, again, I've highlighted some issues here. Here we have title. Title, again, might have been useful in a future data analysis, but again, the percentage that's missing is well above 90. So we would not use it in a future analysis. Here, creation date is looking at the start date, which here in this case, we only have 3% that are missing. So probably, going to be a useful variable in terms of creating tenure, like how long has a customer been with the organization. So this really gives us kind of, and I say our first glimpse of the quality. I say our first glimpse of the quality of data for future data analysis. The third report that we look at is the frequency distribution. And again, I'm showing you just some examples to kind of highlight what we look at. We would produce a frequency distribution report literally on each variable, on each file that we receive, either from a client or if I'm working internally from IT, that we, from data that we receive. What what this report is telling me, again, we're always, besides looking at the quality of data, we're also trying to see if we can get some insights. And so this report is telling me, if I look at creation date, you take a look at start date, it's telling me that there's huge growth, or there would appear to be huge growth between 2005 and 2006. Look at the cum percent. And so there's generally speaking, there's overall growth in terms of their customers. If we look at the creation date, so we're seeing overall growth in terms of the year that they started, but it really starts to accelerate in 2006. And so I'd want to understand why. So these reports are very useful in creating ahas in terms of like, why are we seeing this kind of growth between 2005 and 2006? Another reports that we would look at would be what I would call KBM or KPI type reports, where again we're taking a look at some key metrics here, and I've just included or I'm just for demonstration purposes, I'm looking at record count, purchase amount, average age, average tenure, and again I put etc. because you'd be looking at these KBMs which are pertinent to the business. The key thing that I'm looking in this type of report is what's happening over time, what's trending. And again, this is, just looking at these variables in a static way is useless. You want to look at these variables and how they're trending over time to see if there's significant changes. And then you want to use that as your starting point to go in and examine. Let's say, for example, why is the average age all of a sudden of my customers? Why is the average age of my customers increased significantly between period 2 and period 3? So these are the kinds of useful reports that you would look at, again, from a trend perspective to see what's been changing over time. Tip 5 is use statistics judiciously. And again, I'm going to spend a little bit of time on this. This is, and again, when I talk about statistics, there are the traditional uses in predictive modeling, linear, logistic regression, shade, neural nets, or deep learning. But we also use statistics in other analytics exercises, which I'm going to show you. So, what I hope to show you in this tip are some of the key things that we've looked at in terms of trying to discern findings and results. So the first thing I'm going to show you, there's a lot of variables here. This is a correlation report we did for an insurance company, and you're seeing the raw output. And again, we would not have presented this to the end client. Only in the appendix might have we have shown this. But what this is illustrating here is it's illustrating the top variables from a univariate standpoint that correlate against claims. So here we have a regional variable, which is looking at the forest citation area, and this is our strongest variable in terms of the likelihood of a customer having a claim. So our target variable is claim, yes, no. And so we're correlating all these other variables against that target variable of did they have a claim. And so the utility of this report is it actually ranks it. It actually ranks all these variables from top to bottom. So we have regional variable here. I have one, which is a stats can variable from family, another stats can, which is education. Then I have historical. I'm looking at historical number of claims, so prior to that period. As I said, I'm not going to go through all the variables. The key thing to get out of this is the fact that I've ranked all these variables from top to bottom in terms of correlation, in terms of their correlation to the target variable, which in this case is claims. This report I've used probably thousands of times for different clients. Why? Because it gives me an immediate sense of the strongest variables that are impacting a target variable. Again, in a univariate way, not a multivariate way, but it gives me a very, very quick, it is really my first statistical glimpse of what variables are most important against the target variable that I'm trying to predict. So this has been perhaps my most often used statistical report. Next one is analysis. again, I don't want to point all the numbers here. This is looking at a report that we did. You're looking at the kind of the output that we would have examined in the back room. What you're looking at here is a heat map, which looks at all the correlations between products that that would be in a basket analysis. And the green, the strong green, would be those products that have a highly strong positive relationship, while the strong red would represent those products that have a negative type of affinity. So we were trying again to get insights and learning that tried to say, okay, what is the best basket of products that this company should present to clients when they come into the store. And so we would have done, we would have looked at, again, this type of report along with others. Again, correlation report, but a massive correlation matrix looking at products against other products. Third type of report that we do, and some of you may I'm sure, are familiar with factor analysis. Factor analysis is a unsupervised technique, as most of you know. What is very useful in this is the ability to reduce data, to actually take a look at maybe perhaps a high number of variables and reduce it into a manageable set. And what I've done here is I've tried to kind of illustrate an example here where we have 9 variables. And what the factor analysis allows me to do is to basically group variables into different factors or dimensions. And I'm able to do that based on what we call these factor loading scores. And what this tells me is factor 1, these 3 variables, income, education, and wealth, seem to relate to affluence. While in factor 2, I have products A, B, and C, which seem to pertain to that dimension. And upon further investigation, we may find out that these relate to a particular product category. And the same thing here. Products D, E, and F seem to relate to this dimension. So what it does is it allows me to group these variables into one variable, these set of products into another variable, and products D, E, and F into another product category. So again, I'm using the results of my analysis to reduce variables, in this case from 9 to 3. Now, typically, I just want to do this for illustration purposes. Typically, we would do this against hundreds of variables to try and determine, how can we reduce the data more efficiently. Another technique that we use is CHADE. Now, CHADE can be used as a modeling technique, as many of you know, or it is a decision tree type tool. We use it, or we have used it, to group data together. So particularly when we have character level data, and the example here is a variable that we had called employee size, where we didn't have actual numbers, we only had letters down here, A, B, D, B, and C, G, F, and H, E, I, and J. So we only had letters. And what CHADE does, the beauty of CHADE, is it actually groups character level data together. And so typically we had 10 character level outcomes, and we trained it against the target variable of response. And what CHADE did is it created the groupings for us. And so we've gone from basically 10 character level outcomes into 3. And now what I can do with this data is I can create binary level variables off each one of these categories, or even an ordinal level variable or a ranking level variable, where I could say, let's call this let's call this my top performing variable, which I might put as a 1. I would call this my second top performing variable, which I would put as an ordinal value of 2, and then this group I would put as my my top performing group, and I might code that as ordinal value 3. So I could create ordinal level variables or binary level variables on each of these outcomes. But again, CHADE has provided that insight to let me to do that. Now, again, I'm only showing you 10. Typically, we've done this against hundreds product codes. But again, I just wanted to show you this kind of at a simpler level to kind of show you the approach. So just showing you some examples of statistical output that we use most commonly. Really, this chart really encapsulates how we use all these statistical tools in our business. And so here, we have correlation analysis, which again is to help us to explore and identify key variables. Shade is the same thing, and factor analysis. So each of these three reports that you saw are all help us in that exploratory phase as we build models. Cluster analysis, which I haven't talked about, helps us to do segmentation. And to build unique, distinct segments. While these three other techniques, multiple regression, logistic regression, neural nets, and also shade and other types of decision trees can be used to build the final model. So these are really kind of the sort of 7 types of statistical tools that I've used very almost at throughout my career, and have become quite intimate in terms of the output and how to use that output to produce solutions. Is using art and science to build solutions. So often enough, like, you don't have data, or you may say, geez, I don't have the data to do that, or I'm just, so I'm not going to go forward with the project. Sometimes you have to put your creative hat on and think, okay, what do I have? What kind of do I have? So one good example that I've always used is when we were targeting, let's say we were targeting new customers or for a particular company, we would typically use a very simple kind of fish where the fish are. And we use this a lot for not-for-profits. What basically meant was take a look at where their donors are within a given geographic area, divide it by the population, and you create a penetration type of index. And you can actually take that penetration index and rank order all your geographic areas and use that as your targeting tool. And it's worked quite well because it's adhering to that old notion of fish where the fish are. You're going after those areas where you've already had success in achieving lots of donors. Here's another example that I like to always show when, at various seminars that I give. Here we have no customer data, but market research has indicated 3 distinct variables: above average income, immigrants, and larger household size. Well, you say, okay, but there's no customer data. How do we use that? Well, we could use it in the sense that we could go against StatsCan variables and get StatsCan information that relates to those 3 characteristics, which relates to income, female, and landed immigrant. And we could create indexes off each of these 3. And then from each of these indexes, we could create an overall score. So I've actually created an overall index score related to the market research learning that I have. And so for this postal code, I have called it an engagement index of 1.45. I can then take each of these postal codes, which now have this index, and sort these postal codes from top to bottom based on that index, and then overlay the prospects based on their name and address against these postal codes. So again, I have a way now to target. I can now take the information from market research, albeit it's inferred, but at least I have some way of going in and trying to target postal codes that have characteristics that relate to my market research. Tip 7 is establish performance benchmarks. And this gets into the notion of decile or gains charts. So this again is a model I built on response. And what we're trying to demonstrate here is performance, which is basically how well am I rank ordering response rate, which is this column. And again, what we have over here, because we worked with the business people, we knew we knew the revenue that responder would generate, and we also knew the cost, how much costs we were incurring in terms of going to their current customers. This was an upsell model, and from that we could actually calculate the interval ROI. So what was the return on investment for these different deciles? Well, these deciles are ranked from top to bottom, The top decile represents those names that we would deem to be most likely to respond, while the bottom indicates those responders that we would deem least likely to respond. So that's why we're hoping to see good rank ordering, which we do. The interval ROI, obviously, we're going to have higher ROI at the top, and then it starts to drop off. So it actually tells us, this chart is very useful in telling us where to cut off in terms of maximizing our ROI. Another way to present this is actually Lorenz curves, where we take a look at the response rate, the observed response rate on the y-axis, and we have our deciles on the x-axis. Again, these deciles represent what we're predicting. So decile 1 represents those names that we predict to be most likely to respond, while decile 10 represents those customers that we deem to be least likely to respond. And so a good model or a good curve has a steep line. And so you can use this type of technique to compare all kinds of algorithms, to compare different approaches, maybe if you incorporated different data, because at the end of the day, this is what I'm about. How well does it increase the rank ordering or the steepness of this curve? Again, this is where I put my data science hat on. I have no preferred bias to any one algorithm or to data. I let the data and I let the results speak for itself. And again, this is just an example we would have done on the web, where we're analyzing a model at different points in time, and we can see that it's starting to erode. So we're looking at the model rank deciles, and we're looking at the click rate of a particular desired page, and we're seeing this kind of erosion in performance in terms of the model. Tip 5, I really wanted to get to this. I know we're kind of nearing the end, but I really wanted to get to this. This is about overstating. And I see a lot of data scientists, particularly a lot of young people, that will come in and say, geez, I built this great model. I'm fantastic. You have to be careful that what has been done. Number one, they use proper development and validation samples, i.e. if they're building neural nets, but sometimes it could be in the data, the way that they've constructed the data. So here's an example. Here's an example of a mortgage insurance model that we built. So this is looking at the likelihood of somebody buying mortgage insurance. Okay, you can see here the model that was built. We're capturing 80% of all the responders in the top 5%. I can tell you that's too good. I can tell you right off the bat. So my radar would be going off if I saw that, and I'd be going in to investigate. And I don't care what model you built. If you built a deep learning model, I'd still be going in to investigate that. Okay, let's take a look at all the model variables, and I'd be taking a look at the percent contribution to the model. And you can see here that ever bought insurance. So this is looking at previous insurance buyers. Obviously, that makes sense, right? Anybody that's bought insurance before is probably most likely to buy another insurance type product. And that's why that variable is quite strong, but it's 85%, really strong, like not 20% or 25%, but 85. So I'm going, okay, I need to invest, I need to maybe take a look at this more closely. So this is, again, the model variable. So this is looking at them within the model. Then I look at the correlation coefficient, which I've shown you before. Here, the correlation coefficient, which is looking at the univariate, the univariate approach in terms of its impact to the target variable, which is response. Ever bought insurance, the correlation coefficient is 0.75. But look at it in comparison to the other variables. It's at a different scale. So what this tells me right away, taking a look at these two reports, I got to check the data. And so that's when I go in and I check the data, and I'm just showing you some records here. I would have checked a lot more, but I'm taking a look at the target variable of a response, and I'm taking a look at all the model variables. And I'm looking at ever bought insurance. Look at this variable, ever bought insurance. Look at the response variable. All the response outcomes have the same outcome with regards to yes, which is wrong. There should be some people that have not, there should be some situations where, where somebody that's not bought insurance has responded. And so this is telling me, this right away is telling me that the data or something is wrong with the data, because all of my responders have bought insurance. And I should have some responders, should have some that are non-previous insurance buyers. And so what this led us to believe is that the file was not created correctly, that there was no pre and post period done, whereby you want to take a look at the ever bought insurance prior, and again, I repeat, prior to the event of the campaign, so that you're looking at somebody that's an actual previous insurance buyer prior to the onset of that of that mortgage insurance campaign. So you would craft the data in terms of a pre-period and post-period. I'm going to quickly. Do I have time, Justin? Hello? Hello, Justin?
Yeah,
do I have time?
There's a break. So.
Do I have a time? Do I have more time? Okay. So I'm almost finished. So here's tip 9 is interpreting results correctly. So this is a classic case where I have an equation. This is a using more of a traditional model, which is a regression, and we have this kind of an equation, and the equation has a negative coefficient in years. Yet when I look at correlation, both variables, because they're looking at in a univariate context, so the impact of education on response from a univariate standpoint, and you can see that it's positive from a correlation standpoint, but it becomes negative. Obviously, the problem is multilinearity, so we have to kind of either combine these two variables together or eliminate one of them. But to leave this variable in the equation would be wrong, because you're giving this variable a negative impact when we know that the relationship between education and response is positive. Another example is outliers. So here we have outliers where we have this kind of a situation of spend, which is indicating, oh, okay, there's no correlation between spend and response. And when you take a look at it, when you bin it into 4 bins, you can see very clearly that there is a relationship between response and spend. So then again, I think most of you already know that when you're working with the data, you have to do some kind of work to get rid of outliers and to somewhat normalize the data so that this scenario doesn't happen. Tip 10 is basically leverage your solutions. So make sure they can be deployed, and when you're deploying your solutions, you want to check. So if I develop a model and I'm handing it over to, let's say, my data engineer, and he's deploying that model in the cloud, I want to make sure that the model that I've developed is being deployed correctly. And so this is just kind of a very crude example which looks at that. This is looking at a calculated score, and this is looking at what maybe the data scientists would have got. There's a problem here. These scores should be 100% aligned. So you would have to go and investigate what is the data engineer doing that gives a different score when he's deploying the model in the cloud versus what the data scientist developed. And again, we have another example of once you're deploying or implementing these models, you have a question of scores being very different. So here's a look at scores that were developed at one point in time when we built the models, and now the scores are very different. And so why are these scores very different? Well, in this particular case, I didn't have a chance to demonstrate that, but in this particular case, the model is being deployed against a completely different universe. And so it's causing these scores to drop. So all I'm saying, the point of tip 10 is to make sure that you're deploying models if they can be deployed, and that you have QC to check the individual records and distribution of values. Setting up, and then the last thing is you want to be able to measure what you're doing. And this is talking about setting up a measurement and tracking matrix. So anything that you develop, and that's going to be action, needs to be considered with a view of how you're going to measure that. And again, this is just a very simple schematic of how I might measure a model against various communication pieces that I might use in my communication strategy. So just some, I know I kind of had to skim through very quickly, but I wanted to get through all 10 final tips. Is you need to be very focused on your business objective, i.e., what problem you're trying to solve. You need to manage expectations, as I said, and communicate, communicate, communicate. You notice I repeat that 3 times. That's you definitely want to always maintain that kind of free-flowing dialogue. Um, Results that look too good to be true, they probably are. You need to scrutinize them. So even if you have a whiz kid from Waterloo or from MIT or from Stanford that's built this great AI model, and I'm talking about not so much. I'm talking about it in the context of my world, which is consumer behavior, which is where I come from, not image recognition or NLP. But in consumer behavior type models, you need to review that and to scrutinize it. You need to always validate results. Our world is becoming more automated, and we're getting, we seem to be getting, more used to black box solutions. I think we need to be cognizant of that, and we need to have more manual intervention to see that these solutions are indeed working, and just to rely on the machine and to rely on the technology to do it all is a recipe for disaster. And again, this is the last slide. You want to make sure you can influence the behavior you're predicting. So whatever we're doing, we want a way of either targeting the right people, or maybe we can even get some insights regarding communication. So, we again want to, we always are using these tools to impact or influence the behavior. And when I say behavior, the right behavior, not the wrong behavior, the right behavior. And I know I've skimmed through the 10 tips. Data analytics is a detailed process. So there's no ifs, ands, or buts around it. Most of you that do this for a living, you'll appreciate this. That there's a lot of work and detail that needs to be done just with the data. And I think for those of you that are heavy practitioners, fully appreciate that. Industry experience is invaluable. That's why I talked about domain knowledge. When you're trying to identify a problem, you really want to acquire as much domain knowledge about that business as possible. And the more experience you have in that business, the more domain knowledge you have, the better you're going to be able to frame the problem and the solution to solve that problem. And again, the last thing is ROI. Whatever you're doing, can you demonstrate that there is some meaningful benefit, some ROI to the company? That's why we do these things. That's why they hire us. They hire us because we can deliver tools, deliver solutions that are going to achieve meaningful return on investment. And with that, that's basically it. So I'm going to turn it over